one of the most multi-purpose concept actually. Okay, it is used for both supervised and unsupervised. Okay, so these are few takeaways here. Supervised, unsupervised. Okay, in supervised it is used for both regression and classification. Regression and classification. Okay, so that's the whole thing. So effectively, you can use this for each and everything. Okay, there are some fundamental aspects on which nearest neighbors are basically based on. Is my screen visible? Jupyter Notebook screen. Folks online, is it visible? Okay. So it is used for regression, supervised both regression and classification, and unsupervised. So it is based on internally the concept of vector distances. Okay, so what are vector distance and what are various methods to find it? So there are it actually, okay, vector distances means each feature in an n-dimensional space is represented as a vector, isn't it? Each feature, each data object, everything is in a vector. Okay, so here what happens, it tries to find, you use different algorithms to find out the vector distances, and the idea here is if two data is close, I mean if there is one data which belongs to class A and another data is there which is more closer to data of class A compared to data of class B, right, then it is classified data of class A, right, then it's classification. Similarly, there is regression also. A vector is there and the value of, I mean the output for this particular feature data is some continuous data, then there is another vector. So what it does is it finds the distance between these two guys, and from there it actually, so fundamentally nearest neighbors is based on the distance vector. Okay, so there are three types of distance vector methods. One is your L1 distance, L1, one is L2, one is Minkowski. There are three methods. I'll come to details about that, but let me first take one by one concepts. Okay, first I'll go for unsupervised. Okay, this is one of the most, when you go in e-commerce website and see people who bought this, similar products that is internally implemented by nearest neighbors. Recommendation engines, which is the topic which we'll do next week, and I mean how to create a recommendation engine using this. I think somebody, Gangadhar, was interested into this recommendation engine. How do you use recommendation engines? How do you design recommendation engine? And nearest neighbors plays a very important role in that. Okay. Okay. Let's first see unsupervised case. Okay, unsupervised. Okay, unsupervised means you want to find which is like you have a lot of data. You want to find data which is a new point which is closer to existing points, right? Let me create some data set from sklearn dot datasets. Import from sklearn datasets. You are importing this guy, make clusters function. Make blobs. Next. and features 2 and samples 1000. X is your this data, you can see the points, and Y is your, I think, 0 and 1, right? 0, 0, 1, 2. Number of, oh, I didn't mention here the targets. There is 3, but I wanted to. Hmm. Three plots. Anyway, so there are 3 classes. This is 0, 1, 2 data. So let's now plot it. Import matplotlib dot pyplot.
Sir, maybe number of centers.
Huh?
Maybe number of centers.
Centers.
Defining the target.
Centers, yeah. Centers is not centers, yeah. Understood. Okay, so yeah, centers it is. It will tell you how many. ELT. So if you do PLT dot scatter, okay, then X colon comma 0, X colon comma 1, and Y. This is your number of centers, colors basically, right? So what you see here is these are the data sets. Okay, so what we want to do is we want to find out. So okay, this is one set of points. This is one set of points. We want to find out, we using nearest neighbors. We want to find out where is that point and which particular group does it belong. I mean, which is the closest point. Okay. So what will I do here is in the same data set. So minus. So maybe 3 and minus 3 ELT.
Sir, a small doubt.
Yeah.
Without tapping this matplotlib inline, you are getting the image. We are not getting the image.
Yeah, it's actually getting it. So that's, yeah, when I was wondering about it. Without that also, generally the earlier release, maybe there is some changes in the Jupyter new release. Hey, where is this red green point? Is this plotting it or X3? Not seeing this point. See. -3. I think this is the.
Sir, to me it was showing in the top of the image, green dot.
This one is it? No. It was showing earlier?
Yes, sir. While you gave that C is equal to green, at the time it was showing.
Achha, so the visualization that I see here, it was not showing me the color. Okay. Oh, using plot itself, you're seeing maybe because the screen on which I'm seeing it, it's extended screen and it's not showing me that. I mean, basically, the purpose of it was that's okay. I mean, this point does not matter here. All I wanted to show where it is. So this is my data set. Okay, this is my data set. Now, what we want to do is what I want to do is I want to create nearest neighbor. So from sklearn dot neighbors import. Okay, nearest neighbors. Okay, so here NBRS equal to nearest neighbors. Okay, here you have to give two parameters of how much nearest neighbors you are interested in. That means, so here in this case, I want to find my 3 nearest neighbors. So 2 nearest neighbors. Okay, and the other parameter is algorithms. There are a lot of internal algorithms this guy is based on. So you can have ball tree. I'll explain these things in little details. And these are your nothing but distance vector calculation algorithms. I spoke about few techniques L1, L2, and all that. There are certain modifications on top of it. Okay, so there is bell tree, there is ball tree, there is auto, there is KD tree, there is brute. All these techniques are there. Okay, using grid search, you can find out which one is working out better for you. Okay, but these are nothing but vector distances calculation methods found out by different techniques. Okay, technique, and this is your NBRS dot fit. Okay, you give here X data, right? These train now, and now do NBRS dot predict dot k neighbors. If I do this and give any data to it, it will tell you how far is that. Okay, for example, 3 comma minus 3 is there, right? You can see this is the 3 comma 3 comma minus 3. This is the this 420th data is the closest. Okay, let's see which is 428 data. X is 4, right? You can see this is pretty close to this, isn't it? This data. Okay, and this is the distance between this using this method. What we are using KD, sorry, ball tree, right? Using this method, this is some algorithm which is finding the distance method. That's all it is. It is giving you that this particular point is closest to this 3 comma 3, and this is the distance, which is it is calculating using that. So different algorithm might use different distance calculating mechanisms, and you will get different outputs. Okay, so if you configure hit 5 here, it will show you top 5 points. Understood this? These are the distances that is calculated using one of these techniques, and these are the coded. I mean, these are the index numbers in this data. 420. Okay, you can see this is pretty far, and 421, and in fact, this is also very far, right? So 420 is the, and next closest point is 970. Okay, you can see after this 3 comma 0.3, you can see one. This is 970. Okay, so minus 1.8, 1.8, right? So 1.8 means some, I think this is the point it is trying to mention. 1.8 into minus 3, no, not this one, right? This one. All I said, if I put a point, this is 3 comma minus 3, right? This particular point. You see my mouse here, 3 comma minus 3. So it found out this is one closest point and maybe this is another closest point. Yeah. Got it, right? So it actually gave you this result. Is it clear to everybody?
The algorithms include different values for
Hmm?
other algorithms.
Hmm.
Use some other algorithm. It doesn't show the same value.
It might show the same value if you know that, because it is very simple data. So all the algorithm might show you similar result. But if the data becomes, I mean, this is the data with two features only, right? Two columns. If your data becomes more complex, you might see more complex output. Okay, let's proceed further. Okay, so based on this thing, if you load your housing data, okay, and very important stuff here. Okay, so remember we did house price prediction using linear regression, right? So that time we didn't do any standard scaling on the data set, right? It was not required. But in this case, since we are using distance vectors, this all methods are based on distance vectors. Distance vectors are heavily impacted by the column values. Okay, that means if I load house data now, import and as SPD. Let me copy the stuff. Okay, so I think it was here only, right? Yeah, so maybe, here it is. Okay, just note one thing. Okay, note one thing. The price in the square foot column have values which is uh, quite large compared to values in other columns. Agreed, right? They actually, if you use distance vector method, I'll show. This is a very important thing to understand. Internally, and give index column unnamed colon 0. Okay, this is your house data. House data. Okay. So if I do, I'm just applying directly nearest neighbors on it. See the impact. Okay. Please note it. This is a, important thing when you start working on this data sets. Okay. First thing that we'll be doing is NBRS nearest neighbors. Okay, nearest neighbors and neighbors is equal to say 4 and n jobs. Wherever you have n jobs utility, right, please pass it over with -1 so that it can execute faster. Okay, this is yours and NBRs.
Sir, what is this n jobs?
N jobs means if you assign n jobs is equal to -1, you will use all the CPUs of your machine. Okay, otherwise by default it is set to 1. Got it, right? Parallel. Okay. If you do NBRS fit, and here if you're passing house data, okay. Okay, so now it is there NBRS dot neighbors, k neighbors. Okay, just pass some data corresponding to it. Say how you will pass this data, house data colon 2. Okay, you can see here it is returning you 4 houses. Right, this is for first house. Okay, this is for, I mean, the first row. You can see house number 354 is very similar to first data, and the first, see here the diagonal values will be 0 because they are the 0. You're trying to find for 0th house, right? 0th house is at no distance from 0 house, that is the value is 0. Okay, then if you want to see the house data, if you do house data dot ilog 0, this is the 0th house. Okay, and what we realized was these 0th houses house data dot ilog. Okay, so and this is the first house, and you can see here is 354 houses very close to, right, very similar to this. So I'll just mention it 354, right. You will see this that it is of very much similar. Here the floor and total floor does not matter much. Notice this thing, right? It is very much the size and the price is very much controlling the similarity. Okay, this is the important thing about distance vectors. Okay, so before you actually apply this distance vector, you might have to do some standard scaling. So so that all the columns starts playing equal important roles. Normalize it, right? Okay, that's what we have to do now. Okay, we can use min max scaler and you can see the result. So distance, your linear regression is not impacted by normalizing the data. So there is one thing is outlier detection, normalizing the values. There is one thing standard scaling. So what you have to do there is standard scaling. Okay, makes sense to everybody? Standard scaling, that means you would want to make the central tendency of the data 0, right? Okay, so that's the whole idea. So what you can do is from sk learn dot pre-processing import standard scaler std standard scaler. Okay, so Okay, then house data is transformed. Then you can apply this on NBRS dot fit house data, right? NBRS dot k neighbors. Then pass the house data dot colon. You can see here now for zeroth. I mean, this is only one house that you are calculating, zeroth house, and earlier it was house number 354, which was closest, right? Now you can see 178 closest because all the columns has gone equal importance, right? Let's see now what is if you do. I anyway have overwritten the house data, but understood, right? Everybody, is it clear? Somehow my screen is blocked. Just a second. Uh, okay. Uh, right. Okay. I was just the screen was blocked. So I have to disconnect. Okay, so now we can see the house number. So you have to do this standard scalar before this. It can. I mean, of course, if you try to standard scale those regression algorithm, it will get into results very quickly. Okay, but it will not be impacting the outcome. But here it impacts the outcome because vector distances are influenced by vector values. Okay, so this was nearest neighbors. So you using this, you can do similar products, all those things, algorithms you can implement. Next, we'll go to classification using nearest neighbors. Okay, the internally it is all about vector distances here. Okay, so let's do now nearest neighbors for classification.
Sir, screen was not appearing.
Oh, it's not showing the screen. Yeah, just a second. There's some. Is it visible now?
No, sir. Now it's okay, sir.
Okay, so we have this nearest neighbors for classification. Uh, let's see now. Okay, from sklearn dot neighbors import. Okay, so you have inside this you have k neighbors classifier. Okay, so when you are trying to find the best classifier algorithm, this is based on vector distances again. It will try to find how close it is to one class of data, right? Like above we have x and y, right? X was this feature data, y was this. I can use this itself for classification. Okay, NBRS is equal to K nearest classifier. Okay, K nearest classifier and neighbors. Suppose 5. Okay, and of course algorithm also you can mention AD underscore tree. NVRS dot fit X comma Y. You need to pass both of them. Supervised algorithm, not you need to pass both of them. Okay, then NVRS dot predict. Okay, you pass here some X data. Okay, it will predict which class does it belong to. But right, the API remains the same. And another important aspect that this does is it also does K neighbors. It also all nearest neighbors gives K neighbors. So it will find you given a data, it actually finds you that for 0, and this is clear to everybody, that means there is 2 data here, 0 data and 1 data, right? 0 data, for 0 data, this is the next guy which is closest to this. Along with prediction, it can tell you how close it is to some data, right? That is the benefit of nearest neighbors. Okay, this first guy is of course closest to itself, then it is 924, 582 and all that. Okay. So this is about classification with nearest neighbors. A few more things I will be discussing. Okay. So let's see the nearest neighbors for regression. Okay, so let me from sklearn dot datasets import K nearest neighbor. Oh, not dataset. Make make regression and features to and samples open. Right. You can see here there are two part X and Y. Right. One is feature data and one is target data. Okay, so now what we are doing, NVRS is equal to from sklearn dot neighbors import K nearest neighbor. Okay, so what you can NVRS equal to K nearest regressor. In all this algorithm, you pass one thing. One is n neighbors. Based on how many neighbors you want to do this, right? So just let me give some more insight about classification. Other way of seeing this. In case of classification, also what happens? It considers 5 nearest neighbors. That's what we configure it, 5 nearest neighbors. Then based on the majority of the neighbors, it will tell you what is this particular data. Understood this algorithm? So what you have over here is in regression, I mean, that's the reason I wanted to show regression also parallel. In all the cases, you are configuring by default. If you don't configure this, I think nearest neighbors by default is also 5. So for each point, it tries to find which are the closest 5 vectors. Okay, using one of the algorithm technique, that KD tree, ball tree, like all those things, right? You are finding out for each vector which is the nearest vector, and after you find 5 nearest vector, you see what are their classes, and based on who's in majority, the final verdict is that. Is it clear? Okay, so if you are using more than 5 vectors, configure it based on majority, it will be concluded what does it belong. Similarly for regression also. Okay, you say you are configuring 6 years, 6 year, and you, okay, three. Okay, now you do NBRS dot fit x comma y, NBRS dot predict. Okay, then you have x whole into, right? It realizes that this is the value. Let's see y also, y colon 2. This is the actual value, isn't it? It's very close, not so far away, right? So this is the value that it's calculated. So for one point, it finds out 5 nearest point. Okay, then it, using the distance and between the 5 nearest point, it calculates a value. Okay, that okay, if this is the regression for this value, this is the regression value for all these 5 points, what will be the value for this guy? Okay, that's how it does it. Classification understood. It checks 5 neighbors. It's like, the algorithm is like, okay, so suppose there is a lot of people. There are a lot of people. Okay, a few people is of tennis enthusiasts. Few folks are of football enthusiasts. Few folks are of cricket enthusiasts. Okay, and suddenly a new person has come to that community. He will go to the group that interests or suits his interest, right? He will go to that group. Okay, then by seeing the people near to him, you will realize what is this person's interest. That is classification. Okay, so this is how so there are 2 things involved here. First is how you have to find distance between this vector and the other vector. Okay, for that you have any of this algorithm to be used, and you can see here on doing this, you remember Minkowski we discussed, right? Minkowski. So this is the metric function. This is KD tree. Internally we'll be using Minkowski here. Okay, 3 methods, right? L1, L2, Minkowski. Euclidean, Manhattan, Minkowski. Is it clear to everybody? Okay. Okay, few things to understand. Vector distances are heavily influenced by the central tendency of the data. So you should be doing standard scaling before you apply this methods. Secondly, the answer is found, the base concept of nearest neighbor is to predict the outcome. It uses neighbors information.
Does it average out the neighbor's distance?
No. The averaging logic is actually controlled by your algorithm. For distance vector, it will use Minkowski, and after finding Minkowski, it will use KD tree to find its value. Like if you have 5 points, like let's take a classification case. I am surrounded by 5 points, which is closest to me, and 4 of them belongs to one class. 80% of my, like if I show you that. Okay, let me execute this again. Oh, classification. Okay. Now you can see predict probability. You can see here this is anyway pretty close to 0% and pretty close to 100% actually. So I mean, not 9 maybe. Okay, so maybe I can do 20. It's pretty close actually because it's the same as training data, right? It's the two-dimensional vector, so it is not showing. But effectively, that's what actually. So that was the whole idea. Two classes. That's right actually. So you have only two classes here, right? So it is telling you that there is this one yeah. Let me see if I have an API. That's okay. That's the one. If I simply do this predict, it is giving me 1 and 1 for both of them, right? This is a class, and that's what. Okay. Okay, so you can use nearest neighbor as we saw. So unsupervised, supervised, regression, classification both. Okay. So you can also use nearest neighbor for anomaly detection. What is anomaly detection? Anomaly means how far is like outlier or anomaly. Something is not expected. Okay, something is not generally. You have certain data. So if your vector distances should not be beyond this much. Okay, there is the expected behavior which is a vector, and the current behavior which is also a vector. You should see the vector distances between these two vectors is growing a lot. Then you say this is anomaly. Understood how nearest neighbors can be used for anomaly detection? Okay, so you have certain data points, and many of them are marked as anomaly. So you have a new data which you are seeing is very closer to some anomaly data, and you can say this is the anomaly. So it is since it is based on vector distances concept, you can actually use it.
They specify some points as anomaly. First one, we should specify person.
We should specify.
We should specify
Classic. We can do both of them. So we can use nearest neighbors unsupervised technique to find. Okay, but we can connect various dots now. Nearest neighbor, as we discussed, very useful. Okay, so any questions so far? Okay, let's do few other things. Okay, next we'll try to find the best neighborhood size. Okay. Okay. How do you do that? How do you do that? You can do that using grid search. So let me show that using example. Right, because we are like 6.2, we are directly hard coding it, right? Because understood, right? Suppose you are using 3 neighbors. But maybe in 3 neighbors, 2 guys is telling you I belong to class 1 and other one guy is telling to class 2. So what will be your conclusion? That you belong to class 1, right? Suppose there are 10 neighbors. Now, if you go beyond 2, rest of the nodes say, okay, you belong to class 1. And the influence, remember this, if there is something which is closer to you, it is telling you you belong to class 1 versus something little far to you and is in class 2, the class 1 will have more precedence. At the same time, the conclusive result will be combination of these two, right? That means there will be certain weightage of the guy who is near to you. Of course, there will be certain lesser weightage of the guy who is far from you. But if too many people who are far from you are saying the same thing, and one guy is saying something different, which is closest to you, the too many people's decision will override, right? Because maybe that guy is trying to influence you wrongly. Is it clear to everybody? This last point that I mentioned.
Sir, can you please give any example regarding this?
Yeah. So, I mean, I'm trying to explain now why this, what the topic that I'm trying to do now is identifying best neighborhood size. Okay. So, this is the neighborhood size, right? As of now, I have randomly assigned 2 and 6 to that. Oh, okay. Yeah, okay. Then identifying the best neighbor. Because this is a very important parameter. If you make it too less, remember, if you make it too much of it, then you're doing too much of computation. Okay, so these are the things to take care of here. Too much of it means too much will cause a lot of computation. Too little will compute it too early. Okay, so if you take too little, then maybe there is some near to your point. There might be few points which is influencing your result, right? But which may be wrong. Okay, guys, give me 2 minutes. Okay. Okay, guys, we'll take 5 minutes break now. Okay, we'll shift to one. Okay, so we'll resume from identifying the best neighbors, and there's one more thing we'll be doing here on this guy. Is creating radius-based nearest neighbor classifier. Okay, some modification on top. Okay, that will give us a complete understanding around this. And how to use radius-based nearest neighbor for outlier detections. Okay, these two topics. Oh, you also joined the meeting?
Yeah.
Acha, 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 acha. Okay, is the screen visible? Just had to move the rooms. Oh no.
Hello. Hello.
Okay. So the important thing I was trying to tell here is you see this number of neighbors. This is a very
Hello.
okay.
Sir.
The algorithm what it does is based on what is the distance from their neighbor and what is the time. Both of these factors is taken into account, and based on that it concludes whether this based on this behavior from all the neighbors, it concludes what is the class of it, if it is a classifier case. Understood, right? The number of neighbor is a critical information.
Sir. In previous example, we are giving this n neighbor as a value as 6 or 2.
Okay, so what we'll try to do is we'll try to identify how best number of neighbors for this particular case, and we will use grid search for that. Okay. Okay, so I'll use a simple data set, iris data set now. SQL data sets, import, load iris. Okay. Okay, so as we nearest vector, you should always do standard scaling. Standard scaler. Standard scaler. Dot fetch. It is dot data. Okay. Then you have this is your data here. Okay, this is your, I'm sorry, do fit transform. Right. Okay, this is your data here, which is standard scale. Now, what you want to do is you want to find what is the optimum number of neighbors here. Okay, so what will we do is let's create a. Remember the concepts of pipeline and grid search. Time to use them actually. Okay, from scalar dot pipeline import. Okay, pipeline. Pipeline. Okay, pipeline, and here you'll be passing here all the elements. First is you'll be doing is scaling. Is the first thing, and for that we have the standard scalar object, right? Okay, this is your standard scalar. Okay, can you just okay, so while we have this pipeline standard scalar, and the next guy is your KNN here, right? KNN is neighbor. Okay, so we KNN is equal to KNN is neighbor class. Fire. Okay, by default you want to give number of neighbors as 5, but this is what you want to calculate, and number of jobs always give it wherever you are happy to, right? KNN. So this is the next thing that will happen in the model. Understood, right? So you have these two things in the model. Now, and you have to create. Remember grid search from scalar dot grid search import. Right. So your params. What are the params here? Params will be list of dictionary for all of them. So what? Okay, so this is the first KNN double underscore, right? Then you are getting into each parameter and neighbors NAIGHBORS and neighbors. One. List range 1 to understood, right? Okay, so it will try for all of them. Okay, and now what will it do is grid search CV. Why are you giving neighbor sizes here? Because we want to find what is the best size. We default configured it 5, but we don't know if that is the best. Okay, we want to test with 1 to 10 and see which one is best. Okay, see now. Grid, if you have this grid search CV, okay, then it needs the pipeline. You need the params. Okay, you need the CV. How many times will it test it out? Okay, and this is your grid search that you are configuring here. Okay, then you will see LF dot fit. It will take some time. Okay, because it will try with all these possible combinations. But it is making use of multiple CPUs. Okay, so it will happen faster as well. It's done. Okay, but it will. Okay. Okay, now you want to find out which is the best option here among all these possibilities. You do this CLF dot best estimator. This is the best model here, and CLF dot best params. It will give the best params. So number of neighbors, six is most optimal. Understood, right? That is how you got it here. Why are you giving neighbor size here in given sizes? Saujanya, is it clear?
Hello. Hello.
Why are we giving neighbor sizes here? So we want to find out the best neighbor size, because that actually is one of the most important hyperparameter. And using grid search, you obtain that. Also using grid search, I'm not able to hear you. I'm going to put the speaker in mute. Yeah, try speaking now.
Hello. Hello.
Yeah, try speaking now.
Hello.
Yeah, clear. Yeah, tell me.
So we have given the CV value as 5 here. What is it CV value?
CV is cross validation parameter. That means what it will do, it will divide the entire data into five parts. 4 parts it will use for training, 1 part it will use for testing, and it will do this 5 times. And whatever accuracy you get out of it, that is the accuracy here. Understood, right?
Okay, sir.
There is a best score also. Best score. It will give you accuracy. So 96% is the best score here.
Sir, one show that fitting option.
Yeah. You're saying something?
Once display the fit option. CLF.fit.
This one, huh? Yeah. It is telling you in the pipeline that standard scaling is a scaling K neighbor classifier. Okay. And it is.
There I am getting error, sir, that invalid parameter n neighbors for estimator, something it is saying.
You might not this double underscore. That is how you do check.
No, I kept this double underscore, sir, but it was getting the error.
It must be some syntactical information. What is the error, by the way?
1 second. Sir. Invalid parameter n neighbors for estimator K neighbor classifier. N neighbors is equal to 5. Is this correct, sir?
And underscore neighbors. So yeah. I mean, just I'll be uploading this file. Just check whether.
Okay, sir. Then I will check.
Just check. Should buy small stuff. Okay, so the next thing is we are creating a radius-based nearest neighbor. You just want to find out if this nearest neighbor is in this range. Okay, we will use radius-based nearest neighbor in that case.
We're not using radius.
So till now, radius is the resultant of this. Now we'll use radius based. We'll find out, what are the data which is in that radius. You're not controlling with number of neighbors. Okay, radius based nearest. radius based nearest neighbor. So scalar dot neighbors import the radius based neighbors classifier, right? So here it is, and okay, so I'll use the same data set so that I don't have to. Okay. Standard scalar equal to standard scalar dot with transform arrays data. This is your data, right? And we use RNN. Radius based nearest neighbor is not your deep learning RNN. Radius is nearest neighbor, and here you need to mention the radius. Understood, right? This is the distance that you are interested in. You don't want data beyond it. You're not giving 0.5. Okay, and jobs. I mean, personally, you'll see this very useful. Why is this njobs is not there? Njobs 2 minus 1, which tells you we'll be using all the codes, right? Then rnn dot fit f data. Okay, and of course, what is the target? Okay, so here after this, so you want to do rnn dot prediction, and how many? So this is 1 comma. This is the prediction you're doing. You're finding it in the cluster number 2. Right? How many are there? 3. 0, 1, 2, 3. 3, right? So it's in the second stuff. So if you change it to, and it is using the radius distance information. No neighbors, see this, no neighbors found in the test sample 0. You can try using larger radius. Got it, right? This is there that we want to see. It is using the radius concept there. It is saying that, and it's not that somebody is very far, but because that is one option, it will go here. No, it should be within the radius itself. Okay, keep this in mind because these algorithms are really useful when you are. I mean, if you think deeper, not everything is a classification problem, right? So nearest neighbor is a very. It has a. It has more. It has more application compared to a lot of other algorithms in industry. Guys, any questions? Okay, so here you have this. You can see this outlier label. Okay, the syntax I don't remember exactly. Let me check. Outlier label, right? Okay, so just do the help of this to see the API. Radius, weight, algorithm, D size, E metric, Outlier label. Label integer optional default is none. Okay. Label which is given for outlier samples with no neighbor in the. Okay, so I can give here 5. So okay, so all the outliers will be given this label. See here -1 because there's an outlier. Got it, right? Is it clear to everybody? How can you use, so you can say that, it is not closer to any of the existing data. Is it clear, everybody? Okay. For example, you have, okay. So for example, you have some Excel sheet which represents some type of data. Of course, every data you need to use various pre-processing algorithms to convert them into numbers. Once you convert them into vectors, you want to find if there is some data which is not similar to existing data. You can use this technique to identify this data is different. Right? You mark that and mark that outlier. Okay. This is all around nearest neighbors. Let me just quickly see if I missed out anything. It totally consists of 4 topics. This is identifying size, then creating classifier, nearest neighbors. So far so good, yeah. Okay, so there's one topic which I missed out yesterday. I thought of telling you. That is how to save a model, how to reuse a model. Okay, and let's say for example, you have this model created here, right? You have this model created here, RNN. If you do RNN dot, okay, and okay, and okay, so what you have to do is first you need to save this model so that I can mail you this file, and you should be able to use that to do the prediction. Understood, right? So as a developer, you'll be training models, you'll be shipping the trained model, the customer will be using the trained model and put it in for production. So what will you do here? From sklearn dot external, here the externals import joblib. Right. So if you want to save a particular model, you do this joblib dot dump. Okay, write the model name RN in this case, right? Okay, model dot PKL. PKL is a Python pickling technique to convert a model into serialized data structure, so that you can ship it across systems, ship it across libraries, ship it across network, and use it for training and validation. Okay, so you have a joblib dump and you have model.pkl. Okay, so if you do this, it will actually save this in the current directory, right? If I just show it here. You can see this model.pkl. Okay, so what is this guy about? This guy is about saving the model. And now what will I do in this separate file? Okay, I will load this model from, I don't know which library is it using. I don't know anything. I don't need to know anything about it. Let's connect stir nuts in import job loop. Okay, so you do this job loop dot. Okay, job loop dot. I think load the path where the file is present. Model.pkf. When you do this, CLF, it is loading the model. Okay, it is done loading the model. Then you do CLF dot predict 1, 2, 3, got it, right? Just telling you it is out there. So I don't need to know anything. I don't know what is it. You will ship to the customer, you will tell him this is how you use it. You use it for identifying this is what it means. That's it. I don't know it.
If you want to know what it is,
no, you cannot do it. That is the whole idea, right? You don't want your customer to know about it. There's one topic, support vector machines. But before, I don't think I can start on that today. But what will I do is I'll set the background. Okay, things that support, things that, I mean, basically if you talk about logistic regression, what is it trying to do? Basically, it is trying to predict a straight line or a plane which will separate the data, isn't it? It is trying to predict a line or a plane. That's all it is. It does actually. But remember one important aspect. Suppose you have a data which is not linear, which needs the polynomial degree of trying to separate it. Degree 2 trying to separate it. What do you have to do in linear regression? Logistic regression, you have to use polynomial features and convert your data to degree 2, then find the line, isn't it? Right? So you have a huge amount of this. You have to find the degree, okay, which will work out with your data set. SVM works really differently. It will simplify this task. You don't have to think about the degree conversion and then applying also. It's a two-step process, very difficult. So what does SVM does? SVM actually there's a radial bias function we'll need to discuss. Okay, what will it do? It will actually find the best degree to represent your data directly. Okay, just a little background before we do that. So, okay, let me solve some problems now. Okay, so that next week we'll be doing this SVM Monday and recommendation Monday. Okay, because I think now we have less time. So let me solve some problems. Everybody tried that churn data analysis? Didn't get time. Okay, so it's there in yesterday's recording also, churn data analysis, and the code is also there. So try to go through that once. We did do employee exit prediction, predicting which employee will quit the organization. And MNIST we did, right? guys, just a quick check. Did we do MNIST using a random forest? MNIST is handwriting data, the digits handwriting data. Okay. And did we do employee exit prediction, predicting which employee will quit the organization? Oh, we did that, right? Okay. MNIST we didn't do. Okay, so let's see that. This is actually handwriting prediction. Sklearn dot datasets. Load digits. We didn't do this, right? Load digits. Okay. So if you do digits dot shape, it has digits is this digits dot data. If I do, it is this. Each data is represented by data dot shape. Okay. So total there are 1797 images, handwriting images, digits images actually, and each image is represented by a vector of size 64. That means images of size 8 cross 8. Okay. So what you do have to do here is first we want to see the image from import matplotlib dot plot as plt. Okay, so plt.imshow. Okay, I'm showing the first data, digits dot data 0, first row, right? But remember, imshow needs data the shape 8.8. Can you see this? And if you want to see it better, cmap is equal to grid. This is 0, isn't it? Right, 0. And similarly, you can keep changing it. This is some 2, I guess. Okay. If you want to know what is the target, so you do this digits dot data 2, or not digits dot data, digits dot target 2. Understood, right? This is the target value. Okay, that is 2 here, right? You can see this is how to use data. Now you want to create a model which will actually identify this. Okay, given handwriting data, it will tell you what it is. Okay, what is the first thing that you should divide the data into train and test, right? So from sklearn not model selection, import train test split. Okay. sorry. Okay, so we have this train test split. Train X, test X, train Y, test Y, train test split. Right, digits.data is your data. Remember, data, each row is a vector here actually. Digits.data. Understood, right? It is dividing the data. Now we want to use any of the technique. Okay, we can use like earlier that we can create a class, right? We can create a class, and let me do that. We can create a pipeline out of it. Then we'll do this transformations, okay, on the data, and then let's see what to do next. Okay, class email and writing as a classifier. And writing classifier, okay, so def self, because we know now a lot of classifiers. We're going to see which one is best among them. Classifier list. So, okay, and self dot. This is very similar to yesterday's stuff. Okay, pipelines. Just I'm doing this now. Okay, then the function that you write it here is def. You have this guy, right? Create pipelines. Right? Create pipelines. And remember, long back we did PCA, principal components, to identify features. Right? So we'll use PCA also. That is your feature selection technique, PCA. Then create pipelines when you have self. Okay, one is mapper, which is not much required. So one is your transformers, selectors, okay, so you have this self dot, okay, for pipeline, is equal to, I have to import this, right, from sklearn dot pipeline, import pipeline. Okay, so I have to create a pipeline here. Pipeline, and in this pipeline I'll add transformers, TRS, transformers, selectors, and then finally estimators. Got it, right? Estimators. Yes. But here it right for EST in self dot. Got it, right? So you are creating a pipeline at each stage, and after creating the pipeline, what you are doing is you are adding it to that self.pipelines list. Dot append pipeline. It will create pipeline. Once you have created a pipeline, you have to train it, right? Def fit self train x test x. Okay, so fit self train this. Okay, so we'll have to train for all the pipelines. For pipeline in self pipelines, right? Then you have to do pipeline not fit, right? Train x. Sorry, nobody corrected me. Train y. Train y. Right, you are doing the training here. Understood, right? Okay. On after doing the fit part, then you have to will do the score part. The score self dot test x test y. Okay, so we have score here. How do you find score? So for all algorithms, for pipeline dot pipeline pipelines pipeline dot score, right? Test x comma test y. This is the thing that we have to output. Right now your class is ready, isn't it? So let's create the from sklearn dot ensemble import random voice classifier and a boost classifier from sklearn dot neighbors import nearest neighbor nearest neighbor classifier, right? These two techniques are there, and then yeah, and then from sklearn dot svm import svc from sklearn dot decomposition import ECA. Right? Okay, now what will I do is random forest classifier and a boost classifier. HWS. You can of course have the default values here, and let's see. Okay, handwriting classifier. See, list. HWC dot create pipelines, right? Here you need to first give the first thing that will happen here is, see here, transformers, right? So we would want min-max scaler in this case to convert our so that's what we'll do here. From scalar, because here is all pixel values, right? Each value of each data will be between 0 to 255. Now what we'll do is we'll now divide each pixel value by 255, or basically min-max scalar, converting the data between 0 and 1. Okay, so sklearn preprocessing import min-max scalar. Okay, so this is the first thing that will happen here. Min-max scalar. Feature range equal to 0 and 1. Right. The next thing is PCA. PCA needs n components. N component is number of features. It has 64, 18 to 64 features. Rather, we want to reduce this by 32. Right? This is the number of feature representation. Right? And that's all it needs, right? Right. Okay. This is creating pipeline here. Okay. HWC dot fit. Okay. Dot fit. Train X, train Y. Right? Training has been done now. Now if you do HWC dot score. Okay. Test X, test Y. You can see here different algorithm. The first algorithm is giving you pretty high accuracy. Right? Second algorithm is giving you very low accuracy. What is the first algorithm? First is random forest is giving you good accuracy. Anabost classifier is not giving you good accuracy. Nearest neighbor is also giving, so among all this, nearest neighbor is giving you best accuracy, isn't it? And if you increase the number of components, or if you disable PCA and all that, you might change it. That is where grid search comes into picture. Okay, so this is how you can actually write a sample code. Clear with everybody? You can see here, of course, you can pass the data like we did yesterday, LR, those things, and here you can see which algorithm is giving you what accuracy. You can, this is a pipeline, so you can run a grid search on top of it, isn't it? With passing all the pipeline parameters. Five algorithms, 4 algorithms, 5 nearest neighbors, right? Is it clear to everybody? Yes, no? Okay, cool. Okay, let's wrap it up for today. Okay, next we can try all the solving problems. I think everybody is aware of the assignments where they are. Okay, so start solving problems this way approach. Okay, grid search, try to explain it out, see new things that you're exploring. Okay, guys, let's catch up next week. Thank you, everybody. Once scroll up page. Oh, okay. Yeah. I mean, if you want to predict using this, right, you have to write one more function predict. Right, have to implement that. Okay, sure. I'll send it today itself. Okay, as soon as I end the session, it will start saving it, and in 1 or 2 hours, I'll be sure uploading. Okay, take care, guys. Sure, bye. Right? Is there anything, Saujanya, do you want me to wait on something, or is it fine with you now? Okay. Take care, guys. See you next week.